Hi, Dan. So we just collected all of our product through the pilot purification. Now I'm standing in front of this device. What is it?
This is an ultrafiltration skid. This is used for concentrating protein of interest or molecule of interest and buffer exchanging into a new formulation.
So why is this important for making a quality product?
We come out of our purification process at a very low concentration, somewhere between 1 and 10 grams per liter. To administer to patients, we need to be between 100 and 200 grams per liter at the end of the day. When it comes in, it's typically almost looks like water. It's very low concentration, very pure product. There's no impurities really measurable left anymore. We would reduce 1 liter down to less than or equal to 50 milliliters. So this much product becomes this at the end of the day. Sometimes there's trace level impurities like minerals and or vitamins that were in the bioreactor that carry through with the product of interest. And you can kind of see a color difference because as you concentrate that protein up to 200 grams per liter, those impurities will co-concentrate because they're actually attached to the product of interest.
So how do you get rid of those impurities?
In some cases you can't, in some cases you accept them, like vitamin B is a common one, some trace minerals, inorganic metals. They're very acceptable. It all boils down to how much is going to be injected into the patient.
So coming back to this UF-DF skid here, how does it work?
So this becomes your feed or retentate vessel. So your product of interest is usually fed right into this. So your feed pump starts pumping it through your UF device, ultrafiltration device. So it flows into the device and actually goes across the membrane surface. That's why they call it cross flow or tangential flow filtration, because you're actually sweeping that surface to keep it clean and allow permeate to flow through.
And your product's in the retentate?
Yeah, it's in the retentate. And so that retentate will actually return to this retentate vessel. 30 to 40% of the volume that you feed in flows out the permeate to waste, and that other 60% is redirected to your retentate because that's where all your product's being contained.
So what does a filter like this in here look like?
There's actually a lot of little channels in that device. Here, what you can kind of see is we have a device cut open, and as you look through it, you'll see lots of little layers. There's between 50 and 100 layers of membrane in there, and there's a screen in between each layer. That screen is a turbulence promoter, and so that enables you to get the cross flow to operate in a turbulent fashion to clean that surface better. Essentially, your feed goes in these larger pore holes right here and then goes through every channel, and the larger holes on the other end of that device become the retentate ports. While the smaller ports is where the permeate flow comes out of and will flow out of the same device holder in one discrete path.
How much volume will this particular setup here handle?
This will typically handle between 300 grams and about 2 kilograms in a 4 to 6 hour process. So we would come into this process with somewhere between like 30 and 200 liters of load, and we would do that concentration, diafiltration, and recovery process in that 4 to 6 hour process window.
So that's the perfect scale for the pilot facility, I would guess. What do you need to keep in mind when you're scaling up to that commercial scale production?
The feed cross flow rate is the one parameter you need to keep. So we flow at about 300 liters per meter squared hour. So every component on the system essentially gets scaled up while you maintain that constant cross flow rate.
So now we've concentrated and we've exchanged the buffer. Where does the product usually go then?
The final unit operation in a biopharmaceutical process is usually a 0.2 micron sterilizing final filtration step after we recover from this.
Well, thank you so much for teaching us about ultrafiltration, diafiltration.
You're welcome.